Now I need to balance it. I've got 7 carbons in this molecule, so I can put 7 here. There are 16 hydrogens here, I can put 8. I need to count how many oxygens do I have. 14 plus 8 is 22. I'm going to put 11. Is that what you've got? Okay. Next question says heptane can be obtained from the catalytic cracking of, so we're looking at catalytic cracking of hexadecane at a high temperature. Identify a suitable catalyst for this process. What did you put catalyst? Zeolite. That's fine. We can say that's okay. Zeolite. Give one condition other than high temperature. Low pressure. That's fine. Okay. Good. Give an equation for the catalytic cracking of one molecule of hexadecane to produce one molecule of heptane and one molecule of cyclohexane and one other product. So we just need to recall the formulas for them. So we will start with C16H34. It will produce heptane. How many carbons are in heptane, Simon? 7. So I can write down C7H and plus cyclohexane. Now it's a cyclohexane. So the formula for cycloalkanes is, that's the formula. So what will be the hex means? 6. It will be C6H. What is remaining? C3. How much H? Okay, that's fine. So they were just testing you on this section here. And you can say zeolite will come down here. Condition will be there. Next question says alkanes can be used in free radical substitution reactions to produce haloalkanes. Give equation for the propagation step in the reaction of butane to form 2-chlorobutane. Now they have kind of restricted us that we have to produce this product. So I can say propagation means I'll have this plus I've got butane. So butane is CH3, CH2, CH2, and CH3. If you look at it, my product has to be 1, 2, 3, 4. At this location, you need to have chlorine. So it will change into HCl, and this will change into a radical. But when it changes into radical, hydrogen has to be removed from this, or you can remove from this because it does not make any difference because it's a symmetrical molecule. So I'll say it will become CH3, CH2, CH, and CH3, and there will be a radical.
You know when you draw the free radical?
Yes.
So like that one is on top, but you know on the chlorine. Can you draw it like in front of the chlorine?
Yeah, that's fine. Okay, as long as you have a dot next to it, that means there is a free electron. Then this CH3, CH2, CH is a dot, and then CH3 will react with Cl2 to produce CH3, CH2, CH, and Cl, CH3 plus Cl radical. Done? Okay, next question. Now they've given us here, it says CFCs are a group of halogenalkanes currently banned in many countries. They cannot be used as solvents or refrigerants because their effect on the environment. The structure is shown here. Identify the radical produced from this molecule that is responsible for the depletion of ozone in the atmosphere. Now, ozone in the atmosphere, you need to remember the C-F bond is strong and it won't break in the presence of UV light. So we can say it doesn't break in the presence of UV light. But this one will break in the presence of UV light. And will be homolytic fission. So if homolytic fission takes place, then it can produce radicals. So the radical will be this. Now it says explain with the aid of equations why a single radical can cause the decomposition of many molecules of ozone. So we can say Cl dot will react with O3. It will change into ClO radical plus O2. Then ClO radical will react with O3 again, and it will produce Cl radical plus 2O2. Now, if I combine them two equations, the overall equation will be what? The overall equation, this will cancel with this one. This will cancel with this one. So O3 will change into 3O2. And we can make a note here. This has now been regenerated. Therefore, acts as catalyst. That can give us full marks, right? And then say chain reaction will take place. Go ahead, Reach.
Sir, you know the radical dot. Is it okay if I put it on the other side of the Cl?
That's fine. As it's this is just showing that there is electron for this section,
Okay.
and that electron is not part of any bond. Now, yesterday when I was doing the paper for OCR, they had exactly the same question, but they said the radical was not chlorine; it was NO2 radical. What was it? NO2 radical. So the process will remain the same. The only thing that can change in your exam can be this radical might change, but the rest of the things will still remain the same. So instead of Cl radical, I'll have NO2 radical. Here I'll have NO3 radical then. And here it will be, I think it was not, have a look. It was only one marker. It was not NO2 radical, it was NO radical. It was NO radical. So in this case, if I have NO radical, it will change into this radical is. So the only thing that is different here is if I change this equation, I can say it will be O3 and it will be 2O2. Let's put it this way, let's not say anything else. So can you see the only difference between them two equations is that the radical is now NO dot instead of Cl dot. So in your exam, same thing can happen. It was only one marker. Who knows, in your exam it might be 3 markers. Now we'll move on to the last question first. Then we'll move backwards. So let's go to the last question, question number 11. Not a difficult question. It says there are several isomers with molecular formula C6H16 and 2. One isomer is shown. Give the number of peaks in carbon 13 NMR. So I have to look how many environments are there. So number of peaks means number of environments. If I look at them, this is 1. They are both the same. This is 2. They are both the same. This is 3 and this is 4. So when it comes to the number of carbon 13 peaks, there will be 4. Next part says state and explain the splitting pattern of peaks for the hydrogen labeled alpha. Now, to see the splitting pattern, what do? We always consider the carbon, which is the next carbon, not this carbon. We'll look at the next carbon. So I've got the next carbon is here. There are 2 hydrogens here. Are these 2 hydrogens in the same environment as these 2? No, they are not, right? They are in different environments. So if they are in different environment, then the rule which is n plus 1 will apply. So in this case, I can say the splitting pattern will be triplet. Sarah, are you with me on this?
Yeah.
So we always look at the next carbon atom. And on the next carbon atom, I can see there are 2 hydrogens, number 1. Number 2 is I have to ask myself, are those 2 hydrogens in the same environment or different? If they are in the same environment, then splitting will not take place. But if they are in different environment, then splitting will take place. It says explanation, so I can say the next C atom has 2 hydrogens bonded to it. Bonded to it, and they are in different environment. The rule is n+1. Now, the next one, I did tell you about this when we were doing condensation polymers. I've got that file open in front of me. Okay, what I'm going to say. So if you go in the booklet, you will see I told you there are few that you have to remember. The ones that you need to remember are terylene. You will need to know the monomers required for that. It's an example of polyester. And then we've got polyamides. And in case of polyamides, you need to know the nylon. So in nylon, we need two different monomers. So it asks you about the one that contains amine group, the one that contains amine group. So the nylon has diamine and plus dicarboxylic acid. So when it comes to the diamine is NH2, CH2 whole 6, and NH2. When it comes to the dicarboxylic acid, this one is C11O-HO-CH2 whole 4 C11O-OH. So in your exam this time, it might be the case that rather than asking you about this one, they may ask you about the dicarboxylic acid. So you need to know both of them. And when they'll combine together, then they will make nylon 6,6. So it says draw the structure of the isomer this used to make nylon 6,6. So the answer for this is. Now remember, if you write down NH2-C6H12 and then NH2, this is not considered correct. Why? Because now I don't know how these 6 carbon atoms are arranged. When I write them like this, then I know they are all in one chain. So be careful with that bit. Next question says, draw the structure of isomer C6H16N2 that contains 2 primary amine groups and has only two peaks in its carbon 13 NMR. So when I say 2 peaks, this means only 2 environments. Which is primary, it means I'll have NH and H, and I'll have N and H and H. How many carbon atoms do I have? 6. How many hydrogens do I have? 4 are gone. How many more do I need? 12. So what if I put C-C, and I can put CH3, I can put CH3, I can put CH3, I can put CH3. If I do this, you can see now they are all in the same environment. They're all in the same environment, but these two are not in the same environment, right? So I'll have one peak will be 4, 1 and 1, 2, 2, 2 and 2. Sarah, is that a bit clear?
Not really. Can you repeat it again?
So I said when the first thing is when you read this, you have to identify this. It has to have 2 environments.
Yeah.
Okay. So what I did is, and if it's primary, this means the ends will be NH2.
Okay.
Okay. Now I can then say I need what is left from this molecule. 2 nitrogens are gone, 4 hydrogens are gone as well. I'm left with C6 and H12.
Yeah.
Right. So I said I need 6 carbons. So I put 2 in the middle. And if I put 3 CH3s or 4 CH3s around it, I've got 3, 3, 6, 9, and 12 hydrogens. I've got 6 carbons as well. Now, in this case, I can see there will be only one peak for them two, and there will be a peak for these 4.
Yeah, that's right. Okay.
1 second, let me see, is there any other possibility in this case? What if I say I have 1, 2? Something here as well, right? But they are both the same. Does it make any difference if I draw the same thing? So I can say this is same as, both are same. I'm gonna write down both are same. So I can say I can have 1, 2. Here I've got NH2. Here I've got NH. Here I'll add CH3. Here I'll add CH3. Here I'll add CH3. Here I'll add CH3. Now, if you look at it, the 4 of them are in the same environment. These 2 are in different environments. So I'll have a peak 1, 4, 1, 1, 1, 1. But they are both exactly the same thing because I've got single bonds here, and single bonds means they can rotate. So if I put NH2 on this side and CH3 there, it does not make any difference. Is that very clear, or does it not make sense, Sarah?
Yeah, it makes sense. But I think the first, even though that one's, they're both the same, I think the first one makes more sense, if that makes sense.
Both are exactly the same. What I'm trying to say here is, because this carbon has single bonds around them, both of these have got 4 single bonds around them, and these single bonds can rotate. It's not like restricted rotation.
Okay.
So
So
in
just
that
the
case,
first one got rotated
yes,
then.
if you put here or you put NH2 there or here, it does not make any difference. They are both the same.
Okay, that's fine.
Let's move on to the next one. Next one is draw the structure of isomer. This that contains tertiary. Tertiary means I'll have N with R, R, and R. And it has only 2 peaks again. So again, 2 environments. Okay. What can I do in this case? What would you suggest, Miss?
You can do carbons CH3 around the
Around N.
Yeah.
Is that what you're saying? N dash N, and here I have.
No, like so put one end N.
If I do this, what's wrong with this one? It can bond end to N, but how many bonds are around each N? Can it have 4? It can have only 3, right? So this is not going to work. So in this case, what will happen is I can have this, but then I can only have 2 O. So if I put here CH3, here C2H5, C2H5, and CH3, how many peaks will I have in this case?
3.
So I'll have 1 and 1. Then I'll have 2 and 3, 2 and 3. So this is not going to work in this case. So I only need 2 peaks, right? So if I say I have 1 N and I've got CH3 here, I've got CH3 here, how many peaks will be for this one? 1. I can say the same thing on the other end. How many peaks will I have for this one? Same thing, right? Now, how many more bonds do I need to add? How many peaks will I have for them? How come 2? There'll be 1 for both of them because they're both in the same environment. Right, so I can say there'll be 1, 1, 1, and 1, and then I'll have 2 and 2. And it's a tertiary one. This is also tertiary. Are you with me on this bit, Sarah?
Yeah, I get this one.
Okay, so we can then say here, can say N dash CH3, CH3, CH2, N dash CH3, and CH3. Count how many carbons are there? 3, 1, 2, 3, 4, 5, 6, and 3, 3, 6, 6, 12, and 4, 16. That's fine. Arich, are we still connected?
Yes, it makes sense, kind of.
Okay, let's get to question number 10 now. This question is about infrared spectra. A, B, and C are those of primary amine. Primary amine, it contains NH2. A tertiary amine means you'll have R, R, and R. And nitrile means it contains C triple bond, but not necessarily in this order. So what you will need to do is you'll have to make use of this data. This will be given on the data sheet. If I look at the data sheet, I can see here, it tells me for amine, there will be a peak for 3300 and 3500. But this peak will only be there if my amine has N-H. If my amine has N-H. So which one has a peak between 3300 and 3500? 3300 and 3500. Come on, check. Which one has absorption? So this one has absorption here. This is for N-H, which is my primary. Sarah, does that make sense?
Yeah.
Okay, so look, I've already annotated on the question. Primary means NH2. Tertiary means it doesn't have any NH bond. So it will not show any peak in this region, because it won't have N-H bond, right? So the one that shows N-H bond, that will be for the primary A, and that's, yeah. Now let's quickly have a look at the other one. The one that will have nitrile will have a peak between 22,220 and 2,260. Which one has that peak? Which one? I can see this is for C triple bond N peak. So it is. I can say it is nitrile. So nitrile is A, primary amine is C, and tertiary will be then B. So it's C, D, A. Next question says there are 3 secondary amines that contain 4 carbon atoms per molecule. Draw the skeletal formula for these 3 secondary amines. Secondary amines means you have N dash R, H, and that's my secondary amine. Now, how many carbons does it contain? 4 carbons. It contains 4 carbons, and it says draw skeletal formulas. I have to draw skeletal formula. So I'm not good at drawing skeletal formula. So first I'll draw the other one. So 4 carbon atoms means 1, 2, 3. And I can have dash N dash R dash H. Are we happy? That's first one. Yeah, so I put R here. This should have been C. Now I can move it at location 2. So if I move it at location 2, what will it become? 1, 2. That's 2. And for the third one, rather than moving this, I can move one of this to that location. So I can say 1, 2, 3, N dash H dash C. So if I draw them using the skeletal formula, it will be 1, 1, 2, 3. I've got nitrogen, and I'll have a carbon. Next one. 1 carbon, 2 carbons, 3 carbons, and then there's a 4th carbon. For the second one, I'll draw 1 carbon, 2 nitrogen. So 1, 2, 3, 4, and I have to put a hydrogen. For the third one, I can say nitrogen. I've got 1, 2, 3, and then 4. Next one says primary amines can be prepared by the reaction of haloalkanes with ammonia or by reduction of nitride. Now you need to recall halogens with haloalkanes with ammonia will always provide primary, secondary, and tertiary. But if you do reduction of nitrides, it will always produce primary only. I say justify the statement that it is better to prepare primary amines from nitrides rather than from halogen. So I've already given you the answer. So you'll say from haloalkanes, this will produce a mixture of primary, secondary, and tertiary. I can say with nitrides will only produce single product. I want to discuss something here, right? And see on the left side, I've added something called atom economy. So how do you define atom economy? It is the amount of desired product divided by the total mass of the reactants. Mass of the reactants, or you can say mass of the products. So in this case, I can say this one will have higher atom economy. Make a note of that, please, right? So you are only producing one product, therefore you will always end up with more product. My question here, again, output star here. So every single time from a nitride at the end, you have CH2NH2. You will always be at the end. Will always be at the end. That's what you have to remember. Now, for primary amine, we have to produce primary amine with 4 carbon atoms. So I can say 1, 2, 3, 4. At this location, if I put NH2, it cannot be produced because now NH2 is not at the end of the chain. It is always at the end. So you just have to remember this section. If you remember this section, then you will not make a mistake. This cannot be produced from reduction of cyanide. Why? Because in this case, you have CN. Can you change this to CN? You can't, because this one has hydrogen attached to it. Are we happy with that bit, guys? Very important bit that you have to keep in mind. I never knew this, right? I learned it while I was preparing for your class today. Sarah, all good?
Yeah.
Next question. Say the student dissolves a few drops of propylamine in 1 centimeter cube of water in a test tube. Give an equation for the reaction that occurs. Now this is amine. What are amine? Amines are bases. It's similar to ammonia. Similar to ammonia. So when you add ammonia to water, it changes into NH4. It says propylamine. So propylamine is C3H7NH2. Is that it, right? Propylamine. I can say it will be C3H7NH2 plus H2O. It will be reversible because they are, let's say, are weak bases rather than just base. So it will change into CH3, C3H7NH3 positive plus OH minus. Now it says when you add universal indicator to it, what will it change into? So the observation in this case, because it produces OH minus, it will change to color. Next question says phenylamine.
Sir,
Yes.
if you don't, you have to put the thingy sign in the middle, right?
This.
No, yeah.
This is important because it's a weak base, right?
Yeah.
So the concept as ammonia applies when you have, if I was to replace this with ammonia, I still have to put reversible.
Yeah. Okay.
Next question says phenylamine can be prepared. Now, what do you mean by word phenylamine? Phenylamine is, this is what we call phenylamine. Says phenylamine can be prepared by the process involving a reduction of nitrobenzene using tin and an excess of hydrochloric acid. Given equation for the reduction of nitrobenzene to form phenylamine, use H to represent the reducing agent. Explain why an aqueous solution is obtained in this, even though phenylamine is insoluble in water. I did put star on this question as well. So what they're saying is, this is C6H5NH2. What am I doing here? NH2, this will be NO2. NO2. It changes into C6H5NH2 plus 2H2O. I'll add 6 hydrogens here. Are you happy with this bit, what I've just done? Because now I will go to important discussion now. Something which is important for us. Here I have SN in the presence of HCl. Happy? Now what is happening is, this is not soluble, but this is still not soluble. But what is that? What is it that we have? This then will react with HCl and produce C6H5NH3 positive Cl minus, and this salt is soluble. Because you're using acidic conditions. This is my base. So this base will react with acid to produce an ionic salt. And when you produce ionic salt, this salt is soluble. And that's my answer. Again, important bit that you have to keep in mind. And things like these will appear very often. For example, let's say when you're doing hydrolysis of esters, and if you use alkaline conditions, then you will not end up with a carboxylic acid. You'll end up with salt of carboxylic acid. Make sure you know the name of this. This is called phenyl ammonium chloride. I didn't know this name. I learned it today myself. It's absolutely fine if you don't know a few things. Okay, and I'm 100% sure by the time I start teaching this next year, I'll forget it again. Right? I'll have to remind myself. Let's move on to question number 9 now. 2-3 things that you have to remember in this case. Again, I will tell you a few things on your data sheet that you need to keep in mind as well. They've given you here, these are my bases. Now, those who study biology, they should be good at it because they know the base pairs in DNA. So they are always A, T, and GC. So wherever it is A next to it, you'll put T. Wherever it is C, you'll put G. G, C, A, T, G, C. Number one. Number two, you need to remember is between A and T, there are 2 H bonds. Between G and C, there will be 3 H bonds. So the first part is that easy. All I have to do is just write down this pattern T, G, C, A, G. Then I said to you, between A and T, there are always 2 hydrogen bonds. So there will be 2, add, I can say there are 2, add 3, add 3, add 2, add 3. And if you add them all together, how many H bonds do I have? 5, 8, 10, 13. So the answer of the second part is 13 hydrogen bonds. Now, what I want you to do is those who have their, can I borrow yours for a minute? And I'll keep it back to you. So where are these? How are these bonds formed between bases? So I've got A and T. So when it comes to A and T, you have to remember it's this and this section. This will accept a lone pair from this oxygen, and this hydrogen will accept a lone pair from here. So I can say when it comes to these two, there'll be 1 and 1, 2 and 2. Okay. When it comes to guanine and cytosine, you have to remember it is this, this, and this, this, and that section. So this will give lone pair to this. I can say this is 1 and 1. This will accept lone pair from this. So I can say this is second and second. This will accept lone pair from this oxygen. So this is third and third. Now I printed this data book this today. So you have to remember when you go for your exam, make sure you do this is the first thing that you should do on your data book. So that who knows, there could be a 3-mark question in your exam to show the hydrogen bonds between them two or between them two 2-marker. You need to know this, right? Please make sure you remember that. Number 1. I'll come back to it in a minute again. Next part. Now, when it comes to DNA, it's always phosphate, sugar, phosphate, sugar, phosphate, sugar. And here you will have base. Here you'll have base. Here you'll have base. This sugar is always 2-deoxyribose. Are you happy with that bit? Now you have to remember this. This is the molecule of 2-deoxyribose, and this is the phosphate molecule. You have to remember. This section will combine with this section. 1 and 1. Are we happy with that bit? Because this will come and bond itself here below it. So this is where it will get bonded. So when you have OH and OH, one of the water molecule will be removed. So there will be an O bond between, there will be an oxygen bonding this phosphate to this. This section will bond to this section. So I'm going to say this is my 2 and 2. Okay. This is what you have to just show here. So here it says base A is part of a nucleotide in DNA strand shown in figure 2. A nucleotide contains a 2-deoxyribose molecule. An incomplete deoxyribose molecule is shown. Complete the structure to show the nucleotide that contains base A. Base A. You should represent base A at the letter A. And remember, this is where base will get bonded. This is the location of base. So I can say here, I will write down A straight away, because this is where the base will come and bond itself. Then at this location, I will have O, which is then going to get bonded to phosphate. At this location, I'll have O as well. But now I need to add a phosphate group next to it. So I said to you, this is location 2, them 2. Them 2 are location 2. So one water molecule will be eliminated, and this section will bond itself to O-P double bond O-O minus. I'll have dash again O, because this will get removed. And then below it is the section. Now what is remaining? So if I go back to this section here, what do I have here? I need to add some more data here. I did a small mistake here. It should have been, because I said this CH2, this O is next to this carbon. So this carbon is bonded to oxygen. So rather than writing oxygen here, there should be a CH2 first, and then there should be oxygen here, which is bonded to them too. Now you just have to copy the remaining from here. So what is in the what is here at this location? It is hydrogen, 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 and hydrogen. So the main thing that you have to remember is what I just showed you on this. And so when 1 and 1 will combine together, you will subtract H2O. When 2 and 2 will combine together, you will again subtract H2O. Okay. Am I good to move on, people? Question number 8. Now, this question is about amino acids. This figure shows part of 2 polypeptide chains in a beta-pleated sheet of protein. There are different structures of protein. First one, how these are arranged, is my, what is that called, primary structure. This is beta-pleated. The polypeptide chains are held together by hydrogen bonding, as shown. I want to explain how these H bonds are formed. You just have to look. I look at it. For all of them, this is my hydrogen that accepted lone pair from oxygen. Hydrogen accepted lone pair from hydrogen accepted lone pair from oxygen. Hydrogen accepted lone pair from oxygen. So you just have to say lone pair of electrons on C double bond O. Okay, you can show here. It is accepted by electron deficient hydrogen bonded to N, which is N dash H, which is delta plus delta minus. This is again, put star on question 8.2. Now, you need to know about cytosine. Again, you will have to make use of data booklet. What do they say? You've been given complete the structure to show the bond that forms between the side chains of 2 cytosine molecules. Now, have given us any cytosine molecule? No, but if you go back, it tells you clearly, use the data booklet. Use the data booklet. So if I go to my data booklet, this is my cytosine. Okay. In the drawer there. Pull it. So it has CH2 SH. So at this location, you can see what they've done is they've given you this molecule, but it has been given in vertical form. Has been given to you in vertical form like that. Vertical form like that. Is they about the same. Now, once they have done this, all you need to remember is there is a sulfur-sulfur bonding. Sulfur-sulfur bonding. So in this case, it is CH2. I'll put down CH2 dash S dash S dash CH2. And if you remember, I've done this with you, and I did give you this in my notes as well. This is the bond we are talking about. And this bond, this kind of structure is something that's called tertiary structure. That's the tertiary structure. Sarah, are you with me?
Yeah, I'm still with you.
So the next question, it talks about name this type of protein structure. It is tertiary. Now, next question is again from the data booklet. It says structure of the zwitterion of a dipeptide formed by alanine and serine. What is dipeptide? Dipeptide means it is made of two molecules. So which two molecules do we have to use this time? Alanine and serine. Alanine and serine. So if I look at my periodic this data booklet again, they've given us alanine is here, serine is here. So if I combine them two together, what will happen? It's this section that will take part in the reaction. So we'll change into, let's write down first, H2 N dash CH dash CH3 dash C double bond O dash N dash H dash CH dash COOH, and in the at this location I'll have CH2 dash OH. So what I have is, this is what we call dipeptide. This is dipeptide. That's my dipeptide. But the question is not asking me show the formation of dipeptide. It says show the structure of zwitterion. Zwitterion means this section will change to NH3 positive. This section will change to COO minus, and that's my answer. Question number 7. Mr. Anand, where are you? So if I look at this question here, now they're talking about acyl chloride. And we know acyl chlorides are more reactive than carboxylic acid. Remember, there are 3 compounds that you need to remember: acyl chloride, acid, anhydrides and carboxylic acids. They all have same reactions, only the byproducts are different. In case of acyl chloride, you'll form HCl. In case of carboxylic acid, it will be H2O. In case of acid anhydride, it will be carboxylic acid. These are my byproducts. These are my byproducts. Now let's quickly have a look. Here it says they react with aromatic compounds and also with alcohols. So they've given us this acyl chloride. It will react with benzene in the presence of AlCl3. What is this? AlCl3 is my halogen carrier. So what will happen in this case? Again, I'll say the equation will be given equation for the reaction with this to form electrophile. So generation of electrophile, and then we have to outline the mechanism. I can say equation will be CH3 CH2 COCl plus AlCl3. This will change to AlCl4 negative and CH3 CH2 CO positive. Now you have to remember one thing. If I show you this section here, this was like C double bond O and Cl. So in this case, it is C double bond O, and this carbon is positively charged. This carbon is positively charged. Yes, Arij.
So you know the positive doesn't have to be on the carbon.
It is, so it's overall charge, right? We're not saying that it is only for it. I haven't shown it with a bond. If you show it with a bond, then look, I did show it to you over here.
Okay, thank you, sir.
I'm highlighting that bit because you will need to show the movement of lone pair of electron towards this carbon atom.
Got it. Thank you, sir.
So I can then say the mechanism. So for the mechanism, I can say it will be, again, reacts with benzene. This can say it will be C positive double bond O. Here I have C2H5. So electrons will move to this section first. Then it will change into hydrogen and C double bond O, C2H5. What's wrong with my structure? The ring inside is wrong. It should be what? It should be a half ring, like a horseshoe with a positive. Is that it? Okay now. Then I'll say these electrons will be given back to the ring, and as a result of this, this will then change into C2H5. Instruction here. So the organic product in question 7.1 can be converted into an alcohol, shown below. So I can see what they've done is, this is my aldehyde. We can make a note here. No aldehyde. This is my ketone. If it's a ketone, I can reduce it. If I reduce it, then it'll change into secondary alcohol. It will change into secondary alcohol, and that's what we have here. This is my secondary alcohols. It asks us for the name. I did put star there. I'm being very honest, I didn't know the name. I just learned it today. So it will be 1-phenyl, because on the first carbon atom where you have OH, you have got the ring. So it will be 1-phenyl, and then you will say it will be propane 1-ol. In this case, the reagent will be, you can use NaBH4, or you can use LiAlH4. And this is what we call nucleophilic.
Sir,
Yes.
you know how it says phenol?
Yeah.
Can't you put cyclo as well?
You can't put cyclo because this is our benzene ring.
Oh, right.
We
Yeah.
use cyclo for like cyclic compounds,
Oh, yeah, yeah. Okay.
right? So whenever it is ring, when it's a benzene, it will always be phenyl.
Yeah. Okay. That's all right.
There's another option here available to us as well, and that is we can use H2 with nickel. In this case, it will be addition reaction, or you can say hydrogenation. Just for argument's sake, I can quickly show you the mechanism for this reaction. So what happens in this case is, if I have, I'm going to say A, I'm representing ring with A dash C double bond O dash B. So the right side is B. Now this was the case. What will happen in this case is you will have this. This is my nucleophile, which will come from the reducing H. You will then attack on this, and this will go. Agreed. This will then change into A dash C dash B dash H dash O minus. And I have to show the lone pair at this location. Then what will happen? Water molecule will come in. We'll have H dash O dash H lone pairs. And then say this is delta plus, this is delta minus. These lone pairs will come to this. This will then give its electron to that. Okay, and as a result of this, this will then change into A dash C OH dash H dash B plus OH minus. Are you happy with that? To make sure you know this part as well, because it could be something on your exam. It's important bit. Now the next question says the alcohol shown in question 7.2 reacts with ethanol chloride to form an ester. So I said to you, there are three options. We can use ethanol chloride, we can use ethanol. No, we cannot use ethanol. We can use ethanoic acid, or we can use ethanoic anhydride. If I use ethanoic acid, then the byproduct will be water. If I use ethanol chloride, then the byproduct will be hydrogen chloride gas. If I use ethanoic anhydride, then it will be ethanoic acid. In this case, it says the observation. So the observation is about HCl gas. So you say misty fumes of HCl, because that's my byproduct. Says name of the mechanism. What will be the name of this the name of the mechanism will be addition elimination, nucleophilic addition, and then nucleophilic addition elimination. This is the structure of the ester. You can see ethanoyl chloride will be CH3 dash C double bond O dash. This will come and bond itself to O dash C dash H dash ring, and I can have CH2CH3. Now you can see normally over here what they did was the ring and this were facing each other. I'll put ring here and I'll put that one there, but it does not make any difference because these are all single bonds. So there's a rotation. Because of that rotation, it is possible for it to change. For this question again, I do want to show you the mechanism quickly. We can say I'll have A dash C double bond O dash CF. And then when this reaction will take place, the HO dash R, this is my alcohol. Okay, so the lone pair on oxygen will attack. This is delta minus, this is delta plus. Same thing. This will attack there. Bonds will go out, and as a result of this, it will then change into A dash C dash O with lone pair negative. Here I will now have Cl. Here I'll have O, H, and happy OH and R. But there's one more thing that I'll have in this list. What is that thing? Any idea, Simon? Come on. Where? On oxygen, right? Because oxygen gave its electrons, so I'll have to put plus here. Now to get rid of this plus, what will happen then? These electrons will come back, return, and these will go out too. It will then change into A dash C double bond O dash O dash R plus HC. Great. Okay, important bit. Without this, it will be hard for me to answer this question. So I have to have this in my mind. Now I don't have to do my paper, so I don't have to memorize things, but you guys will be doing your paper, so you will need to know. So just for your help, I have taken these out from my notes. And I expect from you people as well, when you are doing your revision, you need to make sure you make notes like these on the papers, so that when you recall, you can make use of that time more effectively. Anyone wants to copy, or shall I move on? Okay. Last question on organic chemistry, and then we are done with more. There's a little bit of more. This last question, as in like detail. This time, what are they doing is they've given you two models, and they're asking you explain the bonding and shape of benzene molecule bonding, and then you have to do comparison of stability. We can talk about bonding first. So I can say each C atom has how many bonds around it? 3 bonds. Now each carbon atom will have how many electrons in total? Carbon has 4 electrons in it. And then if it is bonded to 3 electrons, it has got 3 now. So in total it has 7. Out of 7, 6 are involved in bonding. There's 1 left, and that will be in p orbital. Extra electron is in p orbital of each C atom. What do they do, mate? So p orbitals overlap to make delocalized region. To make delocalized region. So we are done with the bonding. We now need to talk about the shape. When it comes to the shape, what will I say in this case? The shape will be, Simon, what would you say about the shape? So the ring is above and below. So it's not like a pair of electrons. Valence shell electron pair repulsion theory is not going to apply. So if you look at it, each carbon has how many bonds around it? 3. Is there any lone pair? Where is the lone pair? It's just a single electron, which has formed a delocalized region. There's no lone pair, right? So in this case, it will be a planar structure. Planar shape with bond angle will be 120. And we can also say here that C-C bond lengths are equal. Now, the next bit we need to talk about stability. So 3 double bonds will release how much energy? Minus 120 times 3, which is minus 360 kilojoules per mole. Benzene only gives out minus 208 kilojoules per mole. Now, if I take the difference, remember I showed it to you on the diagram. So in case of benzene, it gives out minus 208 joules of energy. 3 double bonds will give out minus 360 kilojoules of energy per mole. So which one? It is more stable by this much amount. How much is this? This will be minus, I can say, benzene is more stable by minus 152 kilojoules per mole. Okay, so it gives out, can make a note, this much less energy is released. I've written minus 152. If you write down 152, that will still get you a mark. Next question. Says the enthalpy of hydrogenation of cyclohexane 1,3-diene is not exactly double the cyclohexene. So what are they saying? This and this. So cyclohexane is this. And this one is that. Now you can see in this case what will happen. We said if you have 3 of these, then the delocalized region is formed, and because of that delocalized region, it becomes more stable. So it's just a value of enthalpy of hydrogenation. So this one will give out how much? Minus 120. It will give, must be less than minus 240. Will give out less than 240. So I can say, when it comes to stress, I can say about 200 kJ per mole, minus 200 kJ per mole. Why am I saying this? Because look, again, these bonds are, because they're next to each other, what will they do? There will be some sort of delocalization. So I can say double bonds form delocalization, therefore get more stable. Okay, therefore structure gets more stable. Done.
So can you just explain it one more time? Because
So what I'm saying is, look, if we have 3 of them, then
yeah.
this structure releases how much energy? So it should release minus 360. But if you go back, it only releases minus 20
Okay.
because this section then changes into this, right? Once you have 3 of these bonds, what do they do? 3 double bonds separated by a single bond, they form a delocalized region. Are you with me on that bit? What I'm trying to say is, if you have 3 double bonds, then technically speaking, it should release 360. But only because of these 3 double bonds forming a delocalized region, so we don't have any more double bonds here. When you have 3 of them, then they will change into a ring. And when they change into a ring, this only gives out 208. Why is that?
Okay.
Because in this case, this has released less amount of energy because of the delocalized region. In this case, we've got 2 double bonds, and they are also separated by only a single bond. So what will happen? They will also form some sort of delocalization in this section here.
Yeah.
And as a result of that, the amount it will achieve more stable state. And once it achieves more stable state, that means the reaction will become less exothermic.
Okay. So the it forming delocalized like electrons makes it more stable then, basically.
Yes.
All right then. Okay.
Now, think about it, right? In your exam, they may say, what if this bond was at this location? Then will it still form delocalization? It may form, right? But if it says that once this bond is at this location rather than 1 3, if it was 1 4, but 1 4 is same as 1 3. Anyways, what I'm trying to say is, if it is separated by 2 single bonds, if it is separated by 2 single bonds, then what would happen in that case? If the amount of energy it released is double the 120, then I'll say no delocalization has taken place, because there will not be any more stable. The structure hasn't become more stable. Are you with me on that, Sarah?
Yeah, I get you now.
I'm saying this, right? So I say when this is the case, then it gives out less than 240 kJ per mole. But if this is the case, then it gives out 240 kJ. What does that indicate? Yeah, this is indicating that no delocalization has taken place. This is indicating that delocalization has taken place. That's why the amount of energy that is being released is not less than 240. Okay, so you'll have to take this into consideration. Now let's get to the next question. This is Arid said she struggles on questions like these. So let's quickly have a look. This time, what is this question is about the rate expression. This is about the rate expression. You have to remind yourself this is based on experimental data. You cannot work it out from the equation. It can only be worked out from the experimental data. Now they've given you all the values here, so we can use these to find K. I can say substitute in this equation to find K. When you do that, you'll end up with a value of K, which will be 13.13. Now you have to be careful about one thing here. Look, all data is to sig. Therefore, this must be to 2 significant figure. Okay, must be to 2 significant figure. Now, in this case, to work out the unit for K, I can see here to work out the unit, I'll do rate is always mole dm to the power of -3 second to the power of -1, and I'll divide this by how many moles? 1, 2, 3, 4. And there are H plus squared. So I'll do mole dm to the power of -3 times by 4. So that will change to mole to the power of 4, dm to the power of 12 minus. Now, if you start simplifying it, 1 mole is gone, 1 mole is gone from here. In the denominator, you've got 3 moles, so it will become mole to the power of -3. From these three of them will be gone. You'll end up with dm to the power of 9, because it will change to -9. When you take it above, it will change to +9, and then s to the power of -1. Now, next part says calculate complete table 2. So once you know the value of k, all you have to do is you plug the values in and you solve, and that will give you the values of k. So when you do that, you'll end up with values which will be here. It will be 0.15. Here it will be 0.26, and at this location it will be 0.4. Reach, are you with me?
Yeah, it makes sense, sir.
So we can now move on to the next section. So on the next section, what they are doing is collected some more data at different temperatures. And what they are now doing is they want us to complete the table. So you have to remember they must be to same dp. These ones must be to you must round them very carefully. So for this one, I have to do 1 divided by t. So when I do 1 divided by t, this gives me 1 divided by 302, and this is my answer. So if you write down 3.3125 times 10 to the power -3, the mark is gone. So you have to make sure you write it to same dp. So it will be 3.31. Now for the next one, I'll do the same thing. It says ln 1 over t. So I'm going to use function ln, fraction sign, 1 over, what's the value of t given to me? Okay, 1 over t has already been worked out for us. I'm going to put this down, 3.70 times 10 to the power of -2. And that gives me answer as this. Now, like I said to you, you have to give your answer to 2 dp. So if you write down 3.29, you've lost that mark again because you didn't round it properly. It's not going to be -3.29. It has to be -3.30. It'll be -3.30. Okay, done. Now what they've done is this is coming from your required practical. You have to know about this because there's a required practical that you do, and you have to make use of this. So what is happening here is this is my equation, which is k equals -ea over r times 1 over t plus c1. This is same form as y equals mx plus c. So in this case, this is my y, this is my c, and 1 over t is my x. So you just have to remember from this equation, if you plot the graph, your gradient will be equal to minus ea over r. Now the value of r will always be known to you. It will be given to you in exams, which it will be either on the data booklet or they may give you an exam like that, right? So 8.31. You'll have to calculate gradient from the graph. R value will come from here, and you can work out the value of EA. So you can calculate EA from here. So let's quickly have a look. Now, on the next page, you can see, before I go on to the next page, what they are saying is, in this experiment, ln k and ln 1 over t, they are both directly proportional. So what they did is they've replaced k with 1 over t. So now my equation is of this form. So on y-axis, I'll have a graph of ln 1 over t. On x-axis, I'll have 1 over t. Now, the next part, if you turn it over, they've already plotted your x-axis. This is my x-axis. I now need to plot the graph for the y-axis. So when it comes to the y-axis, according to my equation, they tell you plot a graph of ln 1 over t on y-axis over here. So on y-axis, where does my value start from? They start from 2.08. So I can go a little bit lower. So I can start from 2 and I have to go up to 4. I have to go to, I can say, here is my 2, 3, 2.5, 3, 3.5, 2. One. You don't have to, right? Because in this case, you have to make sure you cover more than 50% of the graph. So if I put 1, then my first value will be 2.08. This whole section is wasted. Okay, that whole section will be wasted, and we can't do that. So we can say 1, 2, 1, 2, 1, 2. Yes, Arij.
So do you not have to put the squiggly line?
You can, but sometimes they don't look at those kind of things, right?
Oh, okay.
In your case, because all the marks I've seen in past, they don't do that. I generally do that, but in this case, if they don't give you enough space, what would you do? So I can say this is 2. In my case, I'm going to say this is 2.5, 3.0, 3.5, 4.0, and then 4.5. Okay, so now let's have a look. But again, I need to say this is ln1 over t. Now you plot the graph. The first one, when you have 3.21, 3.5, and 3.99 is going to be about 4, right? So I can say one coordinate here. And then I've got 3.30 and 3.39. 3.39 is about 3.4, so I can say at 3.4. Wait. Simon, can I borrow your paper for a minute, please? You copy from my own. I just want to see the values from the previous. Go back to the previous page here. I can see the values now very clearly, and it makes our life a little bit more easy. So let's start from the first one. When it's 3.50, which is here, the value of ln1 over t is 3.99. Where is 3.99? 3.99 is almost there. And I've got the first one. Second one, it says 3.39. Where is 3.39? If you look between 3.3 and 3.4, there are how many? 20 small boxes. So one small box is equal to how much? 0.02. Am I right? So 3.31 to 3.334 and then 3.5. And that's fine. So I can say 2 small boxes is equal to 0.02. No, 0.01. Okay, so look, 3.3, this is 3.31, 32, 33, 34, 0.35, then 36, 37, 38, 39, and 4. So the second point is 3.39 and 3.30. 3.39 and 3.30, so 3.3, 1, 2, 3.3, and at this location. And the third one will be 3.31 and 2.71. So 3.31 is here. 3.39 was over here. So I need to go to number 2.71. So this is 2.5, 2.6, and 2.7. 2.5, 2.6, and 2.7 here. 2. Now there's one more, 2.08 and 3.21. So if you write them down, will make these things will make more sense. This is 3.21. Here it is 3.31. Here it is 3.39. 3.21, 3.31, 3.39, and then 3.50. What I'll now need to do is I'll then join them together. So once I've joined them, I now need to work out the gradient from this graph. My gradient of this graph, to work out the gradient, I need to pick up two values. So I can pick up this value, which was x was 3.50 times 10 to the power of minus 3. This is my x, and my y was, let's say this is 4.0. Then for the other value, I can pick up this value here. This is 3.2, 1, 2, 3, 4. 3.24 and 10 to the power of minus 3, comma, it will be 2.25. What I now need to do is I say, this is my x1, this is my y1, this is my x2, and this is my y1. And I just do y2 take away y1 over x2 take away x1. You may convert this into a triangle and do height divided by base. That's fine as well. But I do this method, so I'll use this method. So I can say it would be 4 take away 2.25 over 3.50 times 10 to the power of minus 3 minus 3.24 times 10 to the power of minus 2. If you put this in your calculator, it'll give you the value. Now remember, what did I say on the previous page? Gradient is always minus EA over. Reach, are you connected, and does that make sense?
It makes sense, but I feel like if I got this question in the exam, I won't be able to do it.
Why would you not be able to do it?
I feel like I'd make like with the whole graph thing, I'd be so confused. Like the whole axis about
This is just the numbers, but you need to know how. This is the important bit to keep in mind. How many boxes represent one division between the two numbers? Always work that out. This should always be your step one.
Yeah, it makes sense also.
And then you work out the gradient. Then if you solve this side, the right side, it will be minus EA over 8.31 equals, if you put this in your calculator, you'll end up with 4.
So we're trying to work out EA.
Yes, that's what we are working out. So this is always, method will always be used to work out the value of A.
Okay, that's fine.
Okay, so any question on this will be used to work out the activation energy for that given reaction. See, one more mistake that I made. These are all negative numbers, so I have to put negative here. I have to put negative there as well. So it will become minus 4, and this will become plus 4. Minus 6730.8. Now, if you multiply that by 8.31, what will happen to this and this? They'll cancel out. It'll give you a value of EA will now be equal to minus 55,932.7. Okay, one more thing that you have to keep in mind is if I go back, what was the unit for R given to me? Joules. So this value will be in. Okay, you have to make sure you know this. This will be in joules per mole. Very important bit. Then you will have to convert it, and then you'll say EA will be then. Now remember, this minus will cancel out, so I don't have to leave this minus here. This minus will not be there. This is activation energy. Activation energy is always positive. This is the amount of energy that's needed for the reaction to start. So it will be 55.93 kilojoules per mole. Let's move on to the next question. Question number 3.5. It says a mixture of isomeric alkanes is produced when pentane 2 is dehydrated. Question like this, make sure you draw the structure. So I've got pentane 2 ordines, 1, 2, 3, 4, 5. It is OH is here, hydrogen, and there are two possibilities. I can have a double bond here if they two will get removed. I can also have double bond at this location if the top two are removed. Okay, so now it says name and outline a mechanism for the reaction producing pentane 1-ene. Simon, go ahead. This is called, are we doing? We are removing H2O. So what will you call it? Yeah, what will the name of this mechanism? If you're removing water, so if you remove something, that reaction is called elimination. So it is elimination. I've missed a few things, right? We should not be doing question number 3 first, because look, I went on to the straight last question. I missed a whole question here. So first, let's do question 4 and then we can go back. It says compound A, B react together to form an equilibrium mixture containing compound C and D according to this equation. A beaker containing 40 centimeter cube of this solution A, second one is B, and third one is C were added to beaker and the mixture was left to reach equilibrium. So we've got 2A plus B reversible sign 3C plus D. So they said here start. At start, how much A was there? They tell you 40 centimeter cube of this dm cubes. You have to convert this into moles. How many moles is that equivalent to? How many moles is that?
I got 6.4 times 10 minus 3.
6.4 times 10. One. For B, I will have 9.5 times 10 to the power of minus 3 moles. And for C, it says 2.8 times 10 to the power of minus 2 moles. And we don't know about D. Now, at equilibrium, you've got A is only now 3.9 times 10 to the power of minus 3. Calculate the moles of B, C, and D in the equilibrium. So we now need to find out reacted for the reactants. So if I do 6.4 take away 3.9, that leaves me with 2.5 times 10 to the power of. Then whatever is produced here, the mole ratio is 2 to 1 for D. If I divide that by 2, this much will be produced for step 1. This is 2 to 1, so half of this will be taken away from it. So I can do 9.5 times 10 to the power of minus 3. Take
So,
away.
sir,
Yes.
you know, so for example, A is 2,000 more than B. So then to find B, you just do 9.5 times 10 minus 3 minus half of
Yes. That's what
3.9 times 10 minus 3.
That's
Okay.
right.
So then for C, would you do a third of it? A third of A then? Or
I will put that in 1 minute.
okay.
9.5 take away 1.25. That leaves me with 8.25 times 10 to the power of minus 3. Now, if you look at A and C, it is 2 to 3. Now, it is hard to work out between 2 and 3. So what I'm going to do is I'm going to change them to 1 to 1.5. 1 to 1.5. Does that make sense? So whatever the amount of A has reacted, 1.5 times of this will be produced. So for this one, okay, this is number 3. Number 4 here will be 2.8 times 10 to the power of minus 2 plus 2.5 times 10 to the power of minus 3 times 1.5. Is it 31.75 times 10 to the power of minus 3?
So I didn't get that for C. For C, I got 6.55 times 10 minus 3.
I've got this.
Let me check again what I done. Oh wait. So you might right. Yeah, you're right. You're right, sir. You're right.
B will be C will be 0.0318 and D will be 1.25 times 10 to the power of minus 3. Are we all happy with that bit, what I did? So this reactor needs to be, yes.
Can you just explain the C one? The
C one. So
yeah.
C, because they said at start they put this much.
Yeah, that's
Okay?
fine.
Nothing happened to this, but from the
Yeah.
reactants, 2.5 times 10 to the power of 3 moles of A reacted. Now, what's the ratio of A to C? A to C is 1 to 1.5.
Yeah.
So how much C will be produced? It will be 1.5 times 2.5 times 10 to the power of minus 3, right? 1.5 times of this will be produced.
Yeah.
What was
So-
original? The original was 2.8 times 10 to the power of minus 2. So I added them two together to work out this.
Okay, yeah, I see what I've done. Okay, that makes sense.
And that makes sense. Now the next part says give the expression for the equilibrium Kc and its units. So the Kc is all its products over reactants. There will be concentration of C cubed, concentration of D to the power of 1 over concentration of B to the power of 1 and concentration of A to the power of 2. Now, in this case, what will the unit? You can see 3 mole dm cube and 4 mole dm cubes above. How many mole dm cube do I have in the denominator? 3. So there will be only one left. So the unit will be mole dm to the power of 3, or you can write it down as mole dm to the power of minus 3. Done. Next question. This question says a different equilibrium mixture of these 4 compounds at a different temperature contained this many moles of B, C, and D in total volume of this much solution. For this temperature, the numerical value of Kc was 116. Calculate the concentration of A. Now this time, again, I'll go back and I see here, because my Kc has unit, I can't use moles in this equation. If Kc has no unit, then I can use moles straight away, because then the volumes will cancel out, but that's not the case in this. So what I'll have to do is I'll have to convert these moles into concentration. So I'll write down Kc will be equal to C cube. How much is that? These are the moles of C. So 1.05 divided by 5.0 times 10 to the power of minus 2. And I'll write down Q because that's C cube times D moles are 0.076 over 5.0 times 10 to the power of minus 2, just 1 over, I don't know the moles of A, so concentration of A to the power of 2 times the concentration of B, 0.21 over 5.0 times 10 to the power of minus 2, and you need to put squares. Now what I did here is I wrote Kc equal. I don't have to write Kc. I can replace Kc with 116. So what you can now do is you can put all of this thing in your calculator. If you do that, you end up with some sort of value. And if you solve it, you'll end up with a value of A being equal to 0.17. Now you have to be careful here. It says appropriate number of significant figure. So I can see in all data, this is the data with least sig fig. So my final answer must have same accuracy, so that must be to 2 significant. Why? Because of this reason. Okay. Now the next part says, justify the statement that adding more water. So what was my equation? My equation is 2a plus b. This gives me c. How many c's are there? 3c plus d. Says justify the statement that adding more water to the equilibrium mixture in question 4.3 will lower the amount of A in the mixture. What would you say? Will lower the amount. Now look, what will happen if you add more water? Adding more water will change concentration of all species, right? Okay, let's say of all. Does that make sense? So this is now linked to what we have been doing with equilibrium involving gases. So if there are gases, which side does the reaction go to? The one that produces more gas to change the pressure. So in this case, concentration will change concentration of all. How? We can say it will go down. Now the system has to increase the concentration. The system will have to increase the concentration. So how will it system increase the concentration? By going to the side that produces more moles, right? You can say system, or we can say equilibrium, will shift to the side with more moles. Now which side has more moles? Forward or backward? Which is forward. So if the forward reaction takes place, what will happen to A? Therefore, A will go down. I put question marks, 3 question marks here because it was a 3 marker. I didn't write for this question, but now because I wrote the equation while I'm teaching you guys, I realized what I had to say. So I just worked out an answer. Okay, again, important bit. Remember, this is similar. This concept has come from which side? It has come from the equilibrium involving gases. Okay, next question. Question number 3. So you've been given 3 different compounds here, and it says here that oxidation of propane 1-ol from propanol and propanoic acid. So oxidation of propane 1-ol can form propanol and propanoic acid. We know if you do reflux, then it will form propanoic acid. If you do distill, then you can collect distillate as propanol. So they've given you the boiling point. It says in a preparation of propanol, propane 1-ol is added dropwise to the oxidizing agent, and the aldehyde is separated from the reaction mixture by distillation. Explained with with reference to the intermolecular forces, why distillation allows propanol to be separated from the other organic compounds in this reaction. So I can say the propanol has no H bonds. Has it got any H bonds? So here only dipole. Well, the other two products, I can say this and these two have H bonds between molecules. In this case, only has dipole between molecules. Therefore, requires less energy. Hence, low BP. What will happen to it? Will boil fast. One more thing you can say, these are strong. Dipole are weak. Easy question. Let's move on. It says give 2 ways of maximizing the yield. Maximizing the yield of propanol obtained by distillation of reaction mixture. So you can see here what is happening here. Propanol has very low boiling point. So if it has very low boiling point, you need to make sure when it distills over, you collect it in a cool container. So you need to collect it in the cool container. So you can say cool distillate. Number one. Number two, what we need to do is we have to maximize the yield of propanol. This means it should not have any impurities in this case. So to avoid any impurities, look, if the boiling point if the temperature goes above 97, then in your distillate you will have propanol and propane mono. So we have to ensure the temperature remains below 90. Temperature must remain below 97. Next one says it does not contain, the sample that you have has not got no propanoic acid. Will say you will add magnesium carbonate. Number two, I can say if no bubbles are produced, what does that confirm? And then carbonate is, and no acid is present. Next question is easy. I'm not going to spend time on this. You just have to make use of equation Q equals M times C times delta T. Then you will have to use H will be equal to Q divided by moles. Now remember, to work out moles, you will have to change these into moles. So the mass of ethanol will be converted into moles. This 150 grams. Yes, yes, Reach.
So, for the previous question, I said add calcium carbonate.
That's fine, any carbonate, but it has to be some named carbonate.
Okay, that's
You
fine.
can use sodium carbonate as well, that's fine. As long as it is carbonate, okay?
Thank you, sir.
No worries, right? So this is your mass of water. And specific heat capacity is given to you as C Okay, and then remember, this value will come out in delta H will then be divided by 1,000, because this Q will give this will come in joules, and this will be joules per mole, and then you have to divide this by 1,000 to change it into kilojoules per mole. So you have delta H from here. This will be in joules per mole, and then you divide that by 1,000, and it'll give you kilojoules per mole. Easy question, not hard. So we're looking at this, we have to work out the mechanism here. I want you to make sure you know this mechanism, because this is very, very important. In this case, what do we have? So I can say I have 1, 2, 3, 1, 2, 3, 4, 5. What do we need to produce? Produce pentane 1E. So it is OH here and H here. So my final product should have double bond should appear here. So I can then say, first of all, there's a lone pair here. H positive will come in. This will be given to this. Okay. Sorry. No, the lone pair always goes towards. So the no, yeah. So this arrow is always going in the direction of the movement of lone pair. Okay, number 1. Then I can say at number 2, this bond will break from here and will go there. And I can also say this will go there. 3 arrows, and then what will happen? Notation with this. Then have 1, 2, 3, 4, 5 double bond here. Now see, this H plus is coming from acid. Okay, and then this H plus gets released, so that will then restore its concentration. So acid is acting as a catalyst. Next one says a pair of stereoisomers. The stereoisomers means E and Z. So in case of E, you have high priority on diagonal. Z has high priority on same side. Says a pair of stereoisomers formed from this reaction. Name the less polar stereoisomer. Less polar. Less polar will be, in this case, it will be E, because C double bond C dash dash dash. I can have H here. I can have H here. I can have CH3 here. And I will have C2H5. The second option will be C2H5, CH3, H, and H. Second option will be this. Now, which one will be less polar? In this case, you've got more electrons on the left below, less electrons above. So this is more polar. In this case, some more electrons are above and quite a few are below. So this is less polar. So I'm going to say this will be my E pent to E. E pent to E.
Sorry,
Now,
why is it? I don't understand why it's less polar.
okay, look, how do you define polarity? For example, let's say if I say BR dash BR, we said in this case, what is this showing? This is showing that more electron charge cloud is on the left side, less is on the right. So this side will become delta minus, this will become delta plus. Are you with me on that bit, Sarah?
Yeah, but
okay,
are we just meant to know that? But
no, this is this is not something that you have to. This is a concept that you must know. Now,
yeah, okay.
Why is this side more polar now? Because it has more electrons on the left. Does that make sense?
Yeah, that makes sense.
Now, if you look at it, how many electrons are above C double bond? 2.
Yeah.
Or how many are below? Quite a lot.
Yeah.
How about in this case? Is it same as this one?
No, it's not the same. It's even
In this case, I can say there are electrons above, there are electrons below as well, but the difference is small. In this case, the difference between the two sides in terms of the electrons is very large. This
Okay.
is more polar, this is less polar side, right?
Makes sense.
I say overall this is more polar, overall this is less polar.
It's polar. Okay.
Does that make sense?
Yeah, yeah.
Okay, so in this case, why is this kind of E and Z polymerization occurs? This is because C double bond C cannot rotate. Number one. And the second condition that we all must need to know is that each carbon atom has two different atom slash groups. Any questions so far? I'm going over the.
No.
Give me 2 minutes and then we can. Last question is a short question, not a very long question. So what is happening here is we've been given halogen alkane. They're used in synthesis, the reaction pathway is shown. So I can see here, this has now been changed. So this is halo alkane, and then from halo alkane to alcohol, and then from alcohol it changes into compound Y, and then compound Y will change into Z. What's the name of this? So the name of the first one here, we can write down 3-bromo. So I will draw it out, right? So I'm going to say this is OH. I've got C, I've got H, and I've got C. I've got CH2 and B. So this is 1, 2, 3. So it will be 3-bromo. 2-methyl propane 1. This reaction occurs via nucleophilic substitution reaction. Why halogen alkane is attacked by nucleophile in this reaction? You just have to say because C-C bond, C-Br bond. This is delta minus, this is delta plus. So this is electron deficient. Therefore, attracts nucleophile. Okay. Now this is more electronegative. You have to say all of this, right? More electronegative, that's electron deficient attached nucleophile. Therefore, lone pair of nucleophile can be donated to C delta plus, which is carbon deficient, electron deficient carbon. Next page. Says the infrared spectrum of compound Y shows a significant absorption in the range of 1680 and 1750. So I'll have to go back again to the data booklet and I see 1680 and 1750. 1680 and 1750 means it has C double bond. It has C double bond, or and it says significant. Draw the displayed formula of compound Y. So if I go back, compound Y is C4H6O2. C4H9O2. Now, can it be, if I see, now there are only 2 options available, right? Because we have gone from here to here. It can either be, what can I say about it? What kind of alcohol is this one? It's a primary alcohol. So it could be either aldehyde or ketone, or carboxylic. No, no, ketone, right? So compound Y will be either aldehyde or carboxylic acid. Now, if I look at it, carboxylic acid 1, 2, 3, 4, then double bond O dash OH 1, 2, 3, 4, 5, 6, 7. Does it make sense? 1, 2, 3, 4, 5, 6, 7, 8. So it can't be carboxylic acid. Can't be carboxylic acid. Now we are left with other option of, and it can't produce this because if you look at it, what was it? We have CH2HO. How many are there? 1, 2, 3. This is OH. We have CH3. This is what I have. This is my compound. And this will change into Y. If it was to change into carboxylic acid, this is all wrong. Right? It doesn't make sense at all. It will form carboxylic acid on this side. If it forms carboxylic acid on this side, then I'll have 3 oxygens. Can I have 3 oxygen in it? I can't because I can only have 2. The only option in this case is it's gonna change into C double bond O H dash C dash CH3 H dash C double bond O dash H. Because that, how many hydrogens has it got? How many do we have? 3, 4, 5, 6. That's right. So this is my compound. So it's aldehyde from here, I can say. Aldehyde or carboxylic acid. But it is not carboxylic acid in this case because if it changes into carboxylic acid, then you'll have 4 oxygen. It can't happen. So it will change into aldehyde. So it will be aldehyde. Compound Z has an empirical formula of C3H4NO. State, give the structure of compound Z. Empirical formula. So that's the reagent for reaction 3. Now it has got N. Where did it come from? N will be, this means if you go to the reactions of aldehydes, you will see aldehydes do react with cyanide. They react with cyanide. So this means cyanide reaction with. And if you remember, whenever it will form cyanide, then it will form 2 functional groups. The product will always have, product will have 2 functional groups. Based on that, I can then say, in this case, the reagent will be KCN and dilute acid. So if I make it react with cyanide, it will change into C-OH-CN to the NC-H-C-H-C-OH-H-C. Are you happy with that bit? And that's my answer. So we are done with this paper. One thing that I found today is that the use of this will be very, very important while you're doing exams. And you must know everything on this. Okay? If you have questions, you can stay behind. If you don't have questions, then feel free to go. Remember, all the lesson recordings are in the folder. So if you have to go through them, you can always go through them.
Thank you, Sir. Allah Hafiz.